All right, so Mars. We all know it as this dry, dusty red planet. But what if I told you it wasn't always that way?
Yeah, it's a real head scratcher.
This deep dive, we're looking at some fascinating research about Mars's past.
Mm.
And get this, we're talking rivers, lakes, maybe even oceans.
Oh, yeah. Billions of years ago. We're talking a totally different Mars, potentially even life-friendly.
Right. And then, somewhere along the line, a major planetary makeover. And one of the biggest culprits, it seems, is Mars's magnetic field. Or should I say, the lack of one.
See, Olt's got this magnetic field, right? It's like a shield. It protects us from all this nasty stuff that the sun throws at us. Solar wind, they call it.
Like a constant cosmic barrage.
Exactly. But Mars, billions of years ago, it's like its magnetic field just went kaput.
Hold on. How does a planet's magnetic field just disappear? What happened?
So picture this. Earth's core is this giant molten ball of iron, right? It spins, and that spinning creates our magnetic field. But Mars, its core, well, it cooled down. And that dynamo, it shut down.
No more spinning, no more magnetic field.
Exactly.
So, no more protection. It's like Mars got left out in the cold, literally, exposed to that relentless solar wind.
Imagine a sandblaster just constantly blasting away at the atmosphere over millions of years, just stripping it away bit by bit.
And that's what we're left with today, this incredibly thin excuse for an atmosphere. But, okay, how do we actually know any of this is true? I mean, it's not like we were there.
Well, that's where the cool science comes in. We have rovers on Mars, right? Curiosity, hard at work over in Gale Crater.
Our little Martian geologists.
And Curiosity, well, found something really interesting. Carbonates.
Carbonates?
Basically rocks that form in the presence of water.
Ah, so we're talking evidence of water. That's huge.
It was a really big deal. But here's the twist.
Okay, there's a twist. I should expect that by now, right?
Right. So by looking at these carbonates, at the different atoms, the isotopes within them.
Okay, isotopes? Maybe a quick refresher. For those of us who don't have a degree in Martian geology.
Sure. Isotopes, they're like different flavors of the same atom. They've got the same number of protons, but different numbers of neutrons. And that makes them slightly different weights.
Okay, I'm following so far.
And by studying these different isotopes, scientists can actually reconstruct past climates, like a fingerprint of what the environment used to be like.
That's fascinating. So, what are these Martian carbonates telling us? What kind of fingerprint did they leave behind?
Well, they're telling us that the water on Mars, it didn't stick around for very long. It was evaporating incredibly quickly, almost as soon as it formed.
Really?
Yeah. Imagine this. Any lakes or oceans that did exist, they were fighting a losing battle against this super intense evaporation. Not exactly ideal conditions for life to really take hold, at least as we know it.
So maybe not the tropical paradise we were hoping for. So we've gone from a planet that might have had oceans to, like, super fast evaporation.
Almost less atmosphere.
That means less protection.
Right.
Which makes you think about all that radiation just bombarding the surface. What does that mean for, us? For our dreams of actually setting foot on Mars?
Yeah, that's the big question, isn't it? And unfortunately, it's not exactly good news.
Oh, no.
Without that thick atmosphere, without a magnetic field, Mars is basically exposed to way higher levels of cosmic rays than we get here on Earth.
Cosmic rays. Okay, that sounds kind of intense.
They are. We're talking high-energy particles, mostly protons and atomic nuclei, and these things are zipping through space at crazy speeds, nearly the speed of light.
Wow.
And they can penetrate, like, spacesuits, even spacecraft to some extent.
Seriously?
Yeah, it's kind of scary when you think about it, like tiny invisible bullets just constantly hitting the Martian surface.
And that's bad for humans, obviously.
It's not good. We're talking about increased cancer risks, damage to DNA,
Yikes.
even potential impacts to the nervous system, the brain, the heart. It's definitely something we have to figure out.
Okay, so that's a lot to process. It's amazing, right, when you think about the power of these cosmic rays, but it also makes you realize just how hostile space can be. But we're humans. We're clever.
Yeah.
There's got to be a way to protect ourselves, right?
Oh, absolutely. We're already working on it. Shielding, for one.
Shielding.
Yeah, like habitats built with special materials that can absorb or deflect those cosmic rays. And it's not just about the materials themselves, but also the design.
Design. What do you mean?
Well, think about it. The shape of a structure, the way it's oriented, it can make a difference. Like, imagine if we could build habitats underground or within natural features that already provide some shielding.
You mean like those lava tubes we see in pictures?
Exactly. Lava tubes, those underground tunnels formed by volcanoes, they could be really good natural barriers against radiation.
That's amazing.
Plus, they might even hold clues about Mars's past, which would be a huge bonus for science.
Wow. So we could be exploring ancient Martian caves and staying safe from radiation at the same time. That's like something straight out of a movie. And all this research into Mars's past, like what Curiosity found in Gale Crater, it helps us figure out how to do this, right?
Absolutely. The more we understand about how Mars lost its atmosphere, how radiation levels vary across the planet, the better prepared we'll be.
So it's not just about surviving on Mars, it's about using what we know about its history, its quirks, to find the safest way to explore it. Which, I gotta say, that's pretty cool.
Yeah.
But it makes you wonder, even if we can protect ourselves from the radiation, what are the chances that anything could have actually survived on the surface for billions of years? Okay, so we've established Mars today, not exactly a walk in the park, but we're talking about billions of years, right? Like, what are the chances that something somewhere maybe hitched a ride on this wild ride and actually stuck around?
It's the question, isn't it? And it takes us back to that early Mars, the wetter Mars. Things were different then.
Right, like completely different. Oceans, rivers, the whole 9 yards. So if life did manage to get a foothold back then, what happened when things started, going downhill? Did it all just poof, disappear?
Well, it's possible, but here's where things get interesting. What if life found a way to adapt? What if it, retreated underground as the surface got harsher and harsher?
You mean like a planet-wide game of hide and seek, going underground to escape all that radiation and the increasingly nasty environment?
Exactly. And we know there are places on Mars that could have provided that kind of refuge.
Those lava tubes again?
Bingo! Natural shelters, potentially, protecting whatever might have been living inside.
Okay, so instead of looking for fossils on the surface,
Yeah.
we should be looking for evidence of past life in these underground hideouts.
It's a huge possibility, and that's what's so exciting about Mars exploration now. We're talking about searching for what we call biosignatures.
Biosignature.
Yeah, like chemical traces, physical traces, things that could only have been left behind by, well, something that was alive.
Like little microbial fingerprints hidden away in the Martian underground. Wow. So it's not just about finding life on Mars. It's about understanding whether life could have actually survived, even as the planet went through this crazy transformation.
It really makes you wonder, right? What else might be lurking beneath the surface, just waiting for us to find it?
I know. Imagine, we find evidence of life on Mars, life that's managed to survive for billions of years against all odds. It would totally change how we think about life, wouldn't it?
Absolutely, it'd be huge.
Well, I gotta say, my mind is officially blown. Lost oceans, hidden caves, the possibility of ancient life. Mars just keeps getting more and more interesting. So until next time, keep looking up. And who knows what other secrets this red planet might reveal.